Japan's entire digital economy is sitting on what you could call a potential gold mine. Today, we're going to dig into the AI revolution that's about to reshape the country and the one single massive roadblock that's been standing in the way. So let's just start with the big number, 100 trillion yen. To put that in perspective, that's over 650 billion US dollars. This is the absolutely staggering value that experts predict AI could unleash for Japan, a number so huge it could define a whole new era of economic growth. But, of course, there's a catch. That entire 100 trillion yen promise is, right now, hitting a brick wall. A single, really critical problem is holding this whole revolution back. So what is it? What is this huge roadblock? What could possibly be preventing Japan from jumping on this incredible opportunity? Well, it's a problem we're calling the data wall. You see, AI models are incredibly hungry for data, but there's this chronic shortage of high-quality training material that is specific to the Japanese language and culture. While AI models in English get to feast on this massive buffet of data, Japan's own innovation has basically been starved, slowing progress down to a crawl.
But what if you didn't have to go out and find more data? What if you could just create it? That is the incredible idea behind a synthetic breakthrough, and it's being pioneered by the IT giant NTT Data.
Okay, so what exactly is synthetic data? Think of it like a perfect digital imitation. It's completely artificial, but it's generated to mirror all the patterns and statistical details of real-world information. Now, here's the crucial part. It contains absolutely no personal or sensitive data. None. That makes it completely private and totally safe to use for training AI. So NTT Data decided to put this whole concept to the test. Their goal was simple: improve an AI that was designed for legal Q&A. They started with their own base model, and they used an open-source toolset from NVIDIA. Now here's where the magic happens. They took just 450 original data points, that's it, and synthetically blew them up into a massive, high-quality data set of over 138,000 samples. And the result of this experiment? It wasn't just a small improvement, it was a gigantic leap forward. Honestly, the numbers here are pretty astonishing. Just take a look at these numbers. The baseline model, with no specialized training, had an accuracy of just 15.3%. Pretty bad. But after they fine-tuned it with those 138,000 synthetic data points, its accuracy skyrocketed to 79.3%. That is a mind-boggling jump of over 64 percentage points. This chart really puts that jump into perspective. I mean, on the left, you've got a barely functional AI. On the right, after training on synthetic data, you have a highly competent, really accurate model. This wasn't just some minor tweak, it was a complete transformation. And you know what? It gets even better. The training didn't just boost the accuracy, it also cured the model of hallucinations. You know, that thing where an AI generates answers that sound plausible but are just factually wrong. Well, after the fine-tuning, it was able to pull out the correct legal terms accurately, without just making stuff up. So this massive accuracy boost was obviously the main goal, but the experiment also revealed some unexpected side effects. You could almost call them superpowers. Usually, when you want to add new knowledge to an AI, you have to do something called continuous pre-training. It's like re-educating the entire model from the ground up, and it's incredibly expensive and slow. But NTT Data found that with enough high-quality synthetic data, they could often just skip that whole step and go straight to supervised fine-tuning. That's more like giving the model targeted lessons, which is way cheaper and a whole lot faster. This technique also solves another huge problem in the industry. As you can see here, an estimated 90% of all valuable enterprise data just sits there. It's completely unused. It's all locked away because of privacy regulations, security risks, licensing issues. It's basically a digital treasure chest that no one can open. Synthetic data is the key to that lock. Because it reflects the patterns of the real data without containing any of the sensitive info, it lets companies finally tap into that 90%. They can train powerful AI models on the patterns from their data without ever exposing the data itself. It's truly privacy by design. So how does a solution for one company become a strategy for an entire nation? Well, this is where the whole idea scales up, moving from a single experiment to becoming the foundation for Japan's very own AI future. As Shinya Higuchi from NTT Data explains, the potential here goes way beyond just legal AI. He says this approach can improve results in areas like market research, customer support, and marketing, where proprietary data is often scarce. It's basically a way to build specialized models even when you have very little to start with. And this leads us to this really crucial concept of sovereign AI. This just means building AI systems that are controlled by a nation and trained on data that truly reflects its unique culture, its language, and its social norms. It's about creating an AI that understands Japan rather than just relying on models trained mostly on Western data.
The grand vision here is to create a national data space. Imagine a collaborative ecosystem where the government and private companies can all safely share the patterns from their data as synthetic datasets. This would fuel a powerful, uniquely Japanese AI, and it would challenge the idea that the future only belongs to a few giant global models.
So what's the single most important thing to take away from Japan's AI breakthrough? It's this: the data wall isn't permanent. It can be smashed. And the tools to do it, like the ones used in this study, are open source and available right now. This is not science fiction. It's a practical solution for today's developers.
And this all leaves us with a fascinating question for the future. Is AI going to be dominated by just a handful of massive global models? Or are we going to see a vibrant world with many sovereign, interconnected AI systems, where each one is an expert in its own local culture and context? Japan's breakthrough suggests that second option is not only possible, but it might already be beginning.